Hello everyone and welcome back to day 8 of the 100 Days of Code Challenge. Today we'll be looking at functions that take inputs. I have just finished watching all the lectures, all the videos actually, and in front of me I have the first exercise of the day. Instructions are right there in front of me. I need to paint a wall, and on the paint it says one can of paint can cover 5 square meters of wall. Given a random height and width of the wall, calculate how many cans of paint you will need to buy. So for example, number of cans equal wall height times the wall width divided by coverage per can. So for example, height equals 2, width equals 4, coverage equals 5. Number of cans that I need will be 1.6, but because you can't buy 0.6 can of paint, the result should be rounded up to 2 cans. Importance: notice the name of the function parameters must match those on line 13 for the code to work, so we have to code it there. I'm going to check line 13. Line 13, yep, okay, so these are some inputs. Check if the code is correct. For example, test equals height equals 3, width equals 9, and then you'll calculate you need 6 cans of paint. By multiplying them together and wait. Wall height is 3, width equals 9. It doesn't say what the coverage is. That is the variables. Needs 6 cans of paint. So 1 can. Okay, all right, fair enough. Equals. Okay, 5 square meters. Okay, perfect. Let me start over here. Run the code. Height of wall 3, width 9. Okay, yep. Let me just copy the code. Well, the text to help me. Comment it out. Write a code behind this. So def, so I need to define a function. Okay. Let's say what's the challenge called? Area calc. Okay, def area calc equals def area calc, and then we're gonna take height and width. Okay. Okay. The first thing I need to do is so if I was to call area calc, if I was to call it, it would be like this, something like this. Now put in 3 and 9 perhaps, but the calculations, height equals just call it H, calling this W. Height equals test underscore H. No. Area equals height test underscore W multiplied by wall width, which will be test underscore W and H. Put that in bracket, divided by coverage. What's wrong now? Let's see what this does. Line 4 area. Oh, so it comes later on. So I can't actually see it. Wait, area equals wall height times width. Yeah, and then number of cans equals area divided by cover, which is this one. Okay, and then I'm gonna try this. Height is not defined. Hmm. I use 3 inputs. Let me just check it again. Width, cover, area equals height and width, number of cans equals area divided by cover. But area is divided there, so what is the issue here? Oh, let me delete this. Ah, 3, 9. So I'm just trying to print it. Print num of cans. Okay, so that's not printing. Height, width, and cover. Yes. Oh, so I have to actually call it this because then we have height there. Width and cover. Oh, okay. All makes sense. No need to worry. Paint. Let's go calc. So this height match that height. Width match that width. Cover match that cover. Area equals height times width. Number of cans equals area divided by the cover. Print. Let me see this. This should work. See, it just requires the perfect. Okay, this Okay, perfect. So now I need to round this up. Round up Python. Try to round the number down. 2.3 and not 3. The ceiling function. Seal. What is the ceiling? Okay. Import math. Print math.seal. Okay. I'll try that. Math.seal for number of count. Yep. This part here. Three, 9, 6. Just the result that I was after. Great, so this is done. But let me just quickly rethink what I did, revisit what I did. Define pin calculator, height, width, and cover. Area, I set calculate to be height time width, and number of cans equals area to our cover. And then it's a print cans. But considering it's a function, it should still do it. Let me delete this part. 3, 9. Oh, it doesn't actually show. I thought it would show based on this. Okay, so that's good to know. Perfect. So that concludes the welcome back to the second exercise of day 8. This should be a quite interesting exercise. What we are trying to do is create a code or program that checks whether a given number is a prime number. And prime numbers are numbers that can only be cleanly divided by itself and number 1. Okay. I need to write a function that checks blah, blah, blah. So for example, 2 is a prime number because it's only even divisible by 1 and 2. So you can only divide 2 by 1 and itself. But 4 is not a prime number because you can divide it by 1, 2, or 4. So if 4 is indivisible by 4 and 1, that'll be all right. But 2 is a third number, so it's not a prime number. So yeah, it's just giving you a quick map of the yellow numbers are prime numbers. And prime numbers are quite important in programming because it's used to everything from cryptocurrency to ciphering to encryption, etc. So yeah, this should be a quite interesting program to write. And let me just have a look. So yep, it should say 73. Okay, it's a prime number. 75, it's not a prime number. Remember the modulus. Make sure you name your function parameters the same as when it's called on the last line of code. Use the same wording as the example output to structure it. Okay, interesting. Let me start this. Let me just quickly run and see what happens. Okay, 78. Okay, yep. Right. So number equals n. Prime checker. Okay. Def prime underscore checker. And we're putting in n. So we are saying if n modulo modulo 2, but that would mean I was going to say modulo 2 equals 0, and it's even indivisible. But 4 is even divisible with 2, but that would not make a prime number. Okay. Let me have a look again. Even divisible by 1 and 2. If n modulo 1 equals 0, print it's a prime number. And then if n modulo 2 equals to 0, print it is, it needs to be, and if n is, and okay, I can probably put it in one line, and n divided by 2 equals 0, print that, else print it is not a prime number. Let me try that. 73, what, line 15. Unspecified argument number. 73. Wait, that's wrong. 73 needs to be a prime number, so I messed up the code somewhere. Okay. First, even this about 1, and n equal to 2 prime. Okay. I don't think it's this simple. Shit. Okay. I'm going to just have a quick look at the solutions for this one, as I'm quite stuck. Right. Okay. So what I can say is prime checker number. I'm just let me have a look at the solutions properly. No. Open new window. Yeah, welcome back. I just had a quick look at the solutions for this one, and I realized I oversimplify things. Yes, there is an if statement, but I also need to apply a for loop. So essentially, yeah, the process of prime number, I need to divide the number by every number from 1. Okay, not 1, because every number divides by 1, but from 2 till the number itself. So I will do for I in range 2 and then all the way to the number itself. And then I will do if number modulo it's even divisible by the number in the range, then it's a prime. I'll just create a variable called is prime equal false. Yep. So, and then up there we'll have is underscore prime equals true. Okay. So we have those, and then so now we also need to do the text for it, right? So I'll do if is underscore prime. If it's a prime, then print it's a prime prime number, right? And then otherwise, well, it's not prime. It's not a prime number. I think that's it. Let me check again. 73 is a prime. Okay, prime number. Perfect. So the code works. But let me just walk through it again. So I'm defining a prime function. Saying if it's a prime equals true for I in range blah blah blah. Up to number, if number is even equal to 0, it's prime. So if these actually divide by any other number in the range, then it's not prime. If it's prime, if prime, okay, so if I usually set true by default, unless it's to specify false. So if it's prime equals true, then print is a prime. Otherwise, print is not prime. Okay, let me just correct that. Okay, great. So that concludes the second exercise of the day. And the next thing is the final project of the day. Back to the final, project of the day and the first part of it. Well, essentially what we're doing is we're creating a Caesar Cipher program, a digital version. And the way it works is in a time of war, Caesar would encrypt his message and by shifting the letters of the alphabet by a specified fixed number. So A will become E, and B will become, B will become E in this instance, D will become A. Essentially the alphabet will just be shifted to the left. And essentially, that's the aim of today's project. And that's something I'll be building out, following these step-by-step to-do lists. So I'm just quickly run it. So at the top we have all the alphabets, all the letters in the alphabet listed out. I'm just run it, type encrypt or decrypt. I'm just saying encrypt first. Type your message, hello, shift number 5. And nothing happens right now, right? Let's build out the code for this. First thing is create a function called encrypt. Def encrypt that takes the text and shift as the input. Text shift. Perfect. Where is the text? Wait. Okay, I can't actually use these names here. It should be another way of saying text. I will call it plain underscore text shift amount identify. So the way it work is create a for loop for letter Wait. Hold on. Where is step 1? Step 1's there. Step 3 is there. Where's step 2? To do 3. Step 3 seems to be missing, but I know what I'm doing. So for letter in plain underscore text, that one, creating a loop, position equals that one, alphabet dot index square brackets, I think. No, letter, index letter, that one. Okay. Okay, so that's the current position. New position equals position plus shift amount, new letter equals alphabet new underscore position, and then cipher underscore text plus equal new letter. All right. I should probably start with a blank cipher. Yeah. Cipher underscore text equals blank. Yeah. Okay. Oh, two is there actually. My bad. Didn't see it. Okay. Let's shift each other. Okay. Encoded text is blah blah. Print output. Okay. Print. Print the encoded text is cipher underscore text, which we have there is blank at the moment. Make that f string. Okay. And then finally, call the encrypt function and pass in the user input. You should be able to test the code and encrypt the message. I'm calling the encryptor encrypt plain text. What shall I put in for plain text? I could just put in any message. Just say something like a greeting or something. Greeting. I shift amount. Okay, let me test this one actually. Hello. And 5 encrypt. Hello. Yeah, that works. Great. Perfect. So that explains that concludes step 1. Let me move on to step 2. Step 2, well, part 2 of the Caesar Cipher challenge project. And in here, okay, so what we've done so far is we've encoded the message, but we also need to decode it, so decrypt it. So essentially we're doing the opposite now. So if you had this text shifted by 5. It should get back to your original message. Okay, so let's do that. Create a different function called decrypt. Def decrypt. And then text in plain underscore text and shift amount as displayed below. Okay, and this time the ciphertext is not blank. It's not plain text. We're taking this. So same here, ciphertext. For letter in cipher underscore text, position equals alphabet dot index, and then this time we'll change the new position. New underscore position equals position minus shift amount. Okay. Plain underscore text plus equals alphabet new underscore position and then print the message. So we print the decoded, what did I say, text. The decoded text is, and then I will just simply select the ciphertext, and then I'll say is so the plain text. Okay, and it's making an F string. Perfect. Step 3, check if the user wanted to encrypt or decrypt a message by checking the direction variable. Then call the correct function based on that direction variable. It should be able to test the code to encrypt and decrypt the message. Okay. So probably an if statement. If direction equals encode, then encode. If elif direction equals decode, so what am I calling when I'm decoding? I'm saying direction equals decode. Decrypt cipher underscore text equals text shift underscore amount equals shift. Yeah. Decrypt. Let me try decrypt one. So this should give me hello. If I select the shift as 5, MJQQT 5. Okay, Not what I expected. Not what I expected. Okay, def, plain text, blah, blah, blah. Ciphertext, shift amount. Oh, plain text. Yeah, I need the plain text. Like I've got the ciphertext there. Plain underscore text equals that. Let me try that again. That's MJQQT. Oh, well, decrypt MJQQT 5. One letter that and position equals alphabet dot index that letter. Boom, boom, boom. Something wrong with my code. It's not printing, outputting the final result. What's the difference between these two? Encrypt. The print statement seems to be fine. Okay, print is fine. I think my entire code is fine, to be honest, but let me see if I can spot any obvious errors. But if direction equals encode, encrypt, plain underscore text, and then shift amount. Yep. Elif direction. You could decode, decrypt, cipher underscore text, shift amount equals shift. Okay. In here, def decrypt cipher underscore text, shift amount, plain text. Yep. For letter in cipher underscore text, position equals alphabet dot index letter. New position equals position minus shift amount. Yep. Plain text alphabet new position. Print the decode the text is plain text. Yep. Okay. This one was fine, but this does not. What is going on? Let me think. Type your message. Decrypt. Maybe I'm calling it wrong. Okay, let me actually maybe I need to encode it first, then I can decode it. Encode. That makes sense. And then hello 5. Okay. So that's that, and then that gives me that. But if I was to go the reverse, it would be decrypt. Oh, it's not decrypt, it's decode. JQQT 5. Great. Perfect. That's done. And then let's move on to part 3 of the. Okay, welcome back to part 3 of the Caesar Cipher challenge project again. Sorry, I keep on saying challenge for some reason because I'm stuck on my mind's stuck on the 100 days of code challenge. But essentially, okay, so the code is done. It works fine. Everything works fine. But now we've been asked to combine the code into a single function. So these two, as you see, there are many things that are overlapping between the encrypt and decrypt. To make things easier, more readable, you just need to combine it. But yeah, as I said, the code works fine properly. This could be a finished version, but I need to combine it as it says in instruction. So def, I need to call it Caesar. Okay. Inputs, plain text, shift amount, ciphertext, shift amount. So I'm gonna call start text, shift amount, that's unique to both, and cipher direction. And underscore text equals blank for letter in start text position equals alphabet dot index letter. Okay, this should work for both of them. Then at the position we have new position. If cipher underscore direction equals encode new underscore position wait, let me do the decode first actually, because we're subtracting with that one. Decode that even. Shift underscore amount multiply equal 1 minus 1. And then new position new underscore position equals position plus shift underscore amount, create space there. And then print the decoded text is and text. There we go. The cipher. Okay, that should. Let me just cut this actually in case I need it again. And then let me try and call it. So Caesar start underscore text equals text, shift underscore amount equals shift, cipher direction equals direction. There you go, direction. Encode. Hello. File. Line 21. Some issues there. What's going on here? Start. Shift on that. Okay, hello. No, wait. Encode. Hello. 5. Let me just look over the code. Okay. Let me see what's going on here. Cipher direction equals decode. Shift amount. And then, oh yeah. Okay, I need the other one as well. No, that seems to be right. So end text for text if cipher equals decode, shift amount multiplied equals 1, new position equals new position. No position, it's not part of the if statement. Equals plus minus 1, and then end underscore text plus equals alpha bet new position. New alphabet new underscore position. Print hair is the direction result yeah, and underscore text. Yep, perfect. So let me try that again. Line 16. Oh, there's some issues there. Oh, F. Yeah. Oh, and the print needs to be outside. Yeah, and same low as the F and for. Let me check the indentations. For if cipher direction equals decode, shift on that. For letter in start text, okay, this needs to be the order I think is a bit messed up. And text is okay. If cipher direction equals decode, shift amount is that needs to go here. Okay. For letter in start text, position equals that, new position that. Perfect, that looks all right. Code, hello, 5. Okay, okay, let me try decode as well. Decode, MJQQT, 5. Hello, perfect. So that works great. So that concludes that. Let me stop right here. Welcome to part 4 and the final part of the project. We're nearly at the finish line. So this should just be a matter of just fine-tuning finer touches to the project, making it more user-friendly and improving on the overall user experience. So yeah, without further ado, let's get started.
All right, so let's talk.
So without further ado, let's get started. To do one, import and print the logo from our part when the program starts. So we have the logo here. I'm gonna do import from art.py yeah, art it should pop up when I type imp from import logo. Yeah, that should be all right. Print, let me just take it out. Yeah, that works. Great. Step 2. What if the user enters a shift that is greater than the number of letters in the alphabet? Try running the program and entering shift number 45. Think about how you can use the modules. Okay, let's try that. It's interesting. Encode gracias. Shift the number 45. Oh yeah, error. Out of range. Okay. Okay. So what we need to do, we need to limit it to the number of letters in the alphabet. Okay, and then I need to modulus. Okay, so I can say so it would be modulus 26, but and then the input number will be so I'll say I have like 26 letters. Shift equals shift. Yeah. Okay. So just move to the end. Last letters. Makes sense. Makes sense. And then step 3. What happens if the user enters a number, symbol, space? Can you fix the code to keep the number, symbol, space when the text is encoded? Start text meet me at 3. Okay. I will do up here. I need to make some changes. Press that. If if character in alphabet position equals alphabet dot index character, new underscore position equals position plus shift underscore amount. Okay, and underscore text plus equals alphabet new underscore position. Wait, no. New position equals position plus shift amount. And end text alphabet new position. And then I'll say else, yes, needs to be an else statement somewhere. Else and underscore text plus equals print. Here's the cipher direction. No, text. Yeah. To do for should can you figure out what to use to restart the Cipher program? Type yes if the user want to go again. Okay. And equals false. While while not should end, and do all of this. Right. No, I need to undo that. Space. No, shift. Yeah, there we go. Shortcut. And then I would say to restart. Restart equals input type yes. If you want to go again, otherwise type no. Backslash n. If restart equals no, should underscore end equals true. Print goodbye. Line 17. What's wrong with line 17? else and text equals car. Yep, there we go. Line 18 now. Okay. The indentation should not be there. Line 20. Damn, there's so many books in my code. Onyx indentation error. Position. I already have it up there, so I don't need it. Code, not the encode. Bonjour. 3, 4, 4. Okay, I definitely need that part of the code. Let me undo. Okay. Let me run that. All this needs to be indented. No. Okay, undo indentation. Okay, yeah, seems to be all right. All right, perfect. So I'm gonna wrap it up here for day 8. I've got a headache. I need to take paracetamol. Today was challenging, but we move.